target on the absolute maximum minimum values. And from the earlier examples, we can make observations that the absolute extreme value, I mean, either local, absolute max, absolute min, if it happens in an interior point, so then that absolute also the local, okay? Like some points that they are both local and absolute because they are interior point. That's one observation. And the next one, absolute extreme values, absolute max, absolute min, also occur at endpoints of the interval of the interest. So it could be happening within the graph or at the two ends for the absolute extreme value. Okay, extreme, that means for the entire graph. I mean, for the absolute extreme for the entire graph as the overall graph or the global picture of the graph. Based on these two observations, we have the procedures like step 1, 2, 3 to locate the absolute max, absolute min. As absolute max, absolute min could occur within or the outside. The one within is also local. If it's local, that means the derivative is zero or doesn't exist. Okay. So for the steps, we're gonna first find the critical value or the critical points. How do we find the critical points? We find the derivative and find out what's c value as the interior point. Okay, interior, because the critical point is gonna be giving you either local max or local min. And then step number 2, find the function value or the evaluate the function value of those critical points that you found from step 1, and also the two endpoints, also two endpoints. And number three is the non-computation part of it. You just compare the values, pick the largest and the smallest. The largest is the absolute max, the smallest is the absolute min. That's it. The critical part would be the first one, find the critical value. And then the second step, you use the algebra skill to compute the function value. The last step, you compare all the numbers, pick the largest, pick the smallest as the absolute max, absolute min. So three main steps to locate absolute max, absolute min. Okay, let's see the first example. The first one, we have the function x to the fourth minus 2x to the third on the interval -2, 2. Okay, problem asks you to find the absolute. Yes, someone has question? No? Okay. Find the absolute extreme value. That means find both absolute max, absolute min. And this is the closed interval. As long as the function is continuous, you have both values. But now we are going to compute what are those values. So step number one, we're gonna find the critical points, maybe more than one. Okay. And step 2, we find the function value of the critical point and the endpoints. And then step 3, find the largest and the smallest. Okay, three main steps. To find the critical points, we have to find the derivative and let it be zero. Also look for the case that the derivative undefined or doesn't exist. Okay. To find the critical point, yes, you're gonna find the derivative. Let's find the derivative. This is not too bad. So f of x equals x to the fourth minus 2x to the third. What is the derivative? Could anyone tell me real quick? What is the derivative of this function?
Uh, 4x cubed minus 6x squared.
Thank you. Thank you, Jonas. So 4x cubed minus 6x squared. And this is the polynomial function. It's only the case that f prime equals 0 because this is a polynomial. The graph is all smooth. So nothing to do with the undefined case because the derivative as a polynomial is all defined. Okay, so we eliminate the possibility to get the critical number down to one single chance that f prime equals 0. Next, we're going to solve for x. How would you like to solve for x? So we're going to solve for x. How would you like to solve for x? When you have 4x to the third minus 6x squared equals 0. Anyone? I should start giving you extra credits for participation. What do you think? Otherwise, nobody like gonna be not many people gonna participate. Jonas, Jeff, and who else? Leah, Serena would be the the regular customer for me. All right, we're gonna solve for x for the equation 4x to the third minus 6x squared equals 0. Could you help me solve for x? Factor out x squared. Yes, thank you, Jeff. So we're going to factor out x squared. What else did we see as a common factor?
2.
2, yes. 4 and 6, we have 2 in common. So factor 2 out. And then the first one becomes just 2x. The second one becomes minus 3. Is that right? Equals 0. Okay. And that means we have this 2x squared equals 0 or give you x equals 0. And the second factor gives you x equals 3 over 2. Okay, 3 over 2. Now you have two critical numbers. Next, we're going to check 0 and 3 over 2 on the interval negative 2, 2. Because we look for the interior point, 0 in, 3 over 2 is 1.5. Yes, in. So we keep both of them. Okay, because we're looking for the critical point as an interior. That means nothing below negative 2, nothing above 2. So we're going to look at these two numbers and use them as the critical numbers. And we got two of them. So critical points at x equals 0 and x equals 3 over 2. So now we're going to find the function value at critical point and at endpoint. Critical point 0, 3 halves, endpoint x negative 2, positive 2. You're going to compute four function values: f at 0, f at 3 over 2, f at negative 2, and f at positive 2. How do you put in a function value? Go back to the given function over there. Do not put it back into the f prime, otherwise you're going to get 0. That's how you obtain 0 and 3 halves, by the way. See the graph? You plot the graph, you can see what's going on between negative 2 and 2. Okay, negative 2 and 2. That's the interval of interest for this problem. And you can see the lowest, okay, at 3 over 2 right there at 1.5, lowest point right there. And at 0 is another critical because the slope is 0. Slope 0, slope 0. Um, and then the two endpoints at negative 2, the value is 32. At positive 2, the value is 0. The value is 0. So with this one, you can verify by the function value. And it's again, what I said is very convenient. You define the function at the first line here. You see the graph comes up, and then use the same function notation and plug in the value 0. The answer is 0. F at negative 2, 32. F at 2 is 0, and so forth. This is another tool that you can use other than the what do you call? Yeah, that's the value at the point 0, point negative 2, which is about negative at 2, at negative 2 is 32. Okay, and yeah, that's a way to verify your answer too when you work on my MATLAB. All right. So from the step 2, that is the one of the easiest tasks that you just plug in the calculator and get the value out. And after that, for the last step, the step that we are going to identify the absolute max, absolute minimum values. Value means the y value. Now, we just compare which one is the largest. The largest is f at negative 2, which is the value 32. The lowest is f at 3 halves. Okay. So we just put them into the answer. The largest, which is the absolute maximum value, equals the f at negative 2, which is the value 32. And it occurs occurs at x equals negative 2. That's how you say at x, the value is 32. And the smallest, which is the absolute minimum value, or the function at 3 halves or 1.5, and the value is negative 1.6875, and occur at x equals 3 over 2. So the answer, looking for the value, so this is the main part of the answer.